Okay, so let's actually look at how we're going to find the mean absolute deviation. Excuse me. So to find the mean absolute deviation, you first have to find the mean of the data set. So you're going to use a dot plot to find the distances from each point to the mean. The third step is you're going to find the mean of all the distances. And let's actually look at an example now that will help you. So let's follow our instructions here, and let's first find the mean of the data set. So if you recall, the way we find the mean is we start by adding up all the numbers, and then we divide by how many numbers we added, which was 5. So the mean of this data set was 3. So I'm now going to did step 1. Step 2 is use a dot plot to measure distances from the mean. So I'm going to go ahead and put a dot on number 1 because we have a data point that represents number 1, another data point on 1, a data point on 2, a data point on 3, and a data point on 8. Now I'm going to go ahead and note right here that this right here, this point right here represents our mean. So we're going to stick a pole there, and we're going to measure how far all these distances are away from that pole. If there's a number on 0, or on 3 rather, because 3 is our mean, this one is going to have a distance of 0. And we're going to use absolute value bars because these are all going to be positive distances, because we're just measuring instead of the distance from 0 like we do an absolute value, we're going to measure how far these numbers are from the number 3. So we could say this first point right here is 0 units away from 3 because it's exactly on the mean. This point over here, if we go ahead and measure how far away it is, this one right here would take 1, 2, 3, 4, 5. So this distance right here is the absolute value of 5 because it's 5 units above the mean. This one over here is going to be 1 unit below the mean. So we're going to take the absolute value of -1 because it's 1 unit below. And then these ones over here are the absolute value of -2 because these are 2 units below the mean. Now, when we find the mean absolute deviation, we're going to go ahead and remember to count these 2 times because there's 2 numbers that are exactly 2 units below the mean. So we're going to go ahead and take the absolute values now and measure those distances, which we just did. We're going to take those distances and we're going to add them up. So we had one that was 2 units away, another one that was 2 units away from 3. We had a number that was 1 unit away from 3. We had one that was directly on 3. And then we had one that was exactly 5 units above the mean. So when we add those all together, we're going to find the mean. So we're going to divide again by 5 because we added 5 numbers. And we're going to go ahead and find that our mean absolute deviation here is 2. This means that on average, most of the points are about 2 units away. In other words, the mean absolute deviation is the average distance of all the values from the mean. It just helps us understand whether the data is really close together or spread out. Since 2 is a pretty small number, we'd say that most of the data is close together. If we had a mean absolute deviation that was larger, like, I don't know, 5 or 10, we could start to assume that the data seems to be more spread out. But since this is a small number, it's telling us that the data tends to be close together. Let's go ahead and try another example. Find the mean absolute deviation of a data set. So the first thing we have to do is find the mean. So let's do that. We're going to go ahead and add up all these numbers. And then we're going to divide by 1, 2, 3, 4, 5, 6, 7, 8. So we're going to go ahead and divide those by 8. We get a mean of 56. The next thing we're going to do is go ahead and find the mean right here. So here's our mean. So we're going to be measuring all the points with how far away they are from that point. So let's plot these. We should end up with exactly 8 dots. We have 1 on 48, 1 on 52, we have 1 on 60, we have 1 on 55, we have 1 on 59, we have 1 on 54, and we have 1 on 58 and 62. Go ahead and make those dots. Now we have to actually measure how far away they are from the mean. So we'll start with this far one over here. This one over here, we could do 56 minus 48. We can see that these have a mean absolute, the difference, between these 2 points would be 8. So we're going to take the mean absolute, the absolute value of -8 because that point is 8 units below the mean. Our next point, if we're going in order here, is going to be this point right here. And if I measure this point is 56, the mean, minus the distance between 52, we get a distance of 4. So this one has an absolute value of -4 because it's 4 units below 56. We're going to take a measurement for 54 now. 54 is pretty easy. We could see that that's the absolute value of -2 because that's 2 units below 0. And then this last one is easy. It's 1 unit below 0. So we're going to take the absolute value of -1. There is no point on the mean in this data set, so we don't have to put a 0 when we find the distance because there's nothing exactly on the mean. We're going to go ahead and measure this far one over here. This one would be 62 minus 56. So we could see that this one would be the absolute value of 6 because it's exactly 6 units bigger than the mean. This one over here is going to be 60 minus 56, or 4 units above the mean. So that's the absolute value of 4. Then we have another one over here. This one, 59, is going to be the absolute value of 3 units above the mean. And this one right here is going to be the absolute value of 2 units above the mean. So since we had exactly 8 points, we should have 8 distances when we find our mean absolute deviation. And we recall that the absolute value is always positive. So we're going to actually write these down as all positive numbers. So I'm going to start with 8 plus 4 plus 2 plus 1, because those are all the absolute values, which means they're going to be a positive number, plus 2 plus 3 plus 4 plus 6. And I'm going to divide that by 8. I always check to make sure I didn't miss a number. 1, 2, 3, 4, 5, 6, 7, 8. So when we do that, we actually get 30 over 8, which is actually going to be equal to 3.75. So our mean absolute deviation for this data set is 3.75. So we could say that this does not have a very large spread because the average distance of a data point is about 3.75 units away from the mean. All right, great job. Thanks for paying attention and listening carefully. So far during this lesson, we actually went over how to calculate the mean absolute deviation for a data set, and you should be able to explain what the mean absolute deviation represents for a specific distribution.